Hi, welcome back. So before the break, we were doing application of the three trigonometry rules. Specifically, we were looking at examples with variables. We continue with that now. Okay, in this example, they've asked us to find the area of the shaded region in terms of x, alpha, beta, phi, and theta. So what we have to first look at the diagram and try and examine all three triangles and see which one has what kind of information that we can use. Our first triangle is triangle ABE, and triangle ABE is a right angle triangle, and we have 2 bits of information, which means it's solvable. Okay, triangle BCD has 3 bits of information. We've got an angle, and a side. And look at this. We have one full pair because we have B and we have the side, we have beta and we have the side across it. So we can probably use sine rule if we are using that triangle. The third triangle we have is this shaded triangle, and that's what they want us to find the area of. But in this triangle, we only have at the moment 1 bit of information. All we're given is theta. So we need to find at least 2 more pieces of information before we can find the area of the triangle. And it seems like we need to use this triangle and this triangle to try and find the sides of our shaded triangle. So what we're going to do is we're going to try and find, let me just grab my pen quickly. Okay, we're going to try and find this side, BE, using this triangle, and then we're going to try and find an expression for BD using this triangle, and then see if we can find the angle in between. So if you look at this angle in between, in the shaded triangle, we could use this angle and the exterior angle to find an expression for that. So we kind of have a plan, we have an idea of what we're going to do. So we're going to find BE, then we're going to find BD, and then we're going to find an expression for that angle. So let's begin. Let me just clear up some of these funny marks they've had to enter up on the screen. Okay. Okay, so we're going to start off with triangle ABD, and we're going to start off with, because we have the adjacent and the hypotenuse, we're going to end up using cos, because cos of phi will be x over this length here, which is BE. So cos of phi will equal to the adjacent side, and adjacent to phi is x, and the length of the side, the hypotenuse, is BE. So remember we said we're going to find an expression for BE. And now if we rearrange this and we multiply throughout by BE, we can just end up with BE equals to x over cos of phi. So now we have an expression for that side. We're going to do the same thing now and use this triangle to find an expression for BD. Okay, so in triangle BDC, remember we already decided we have 1 full pair. Okay, so we can find BD using sine of the angle across it. So BD over sine of alpha, and then on the right hand side we're going to use our full pair. And what was our full pair? That was the side, so x, and the angle across it was beta. Okay, and then when we rearrange this, we're going to multiply throughout by sine of alpha, and we end up with BD equals x sine alpha over sine beta. Now we have an expression for BE and for BD. So there's the 2 expressions we found in the previous 2 slides. BE is equal to x over cos of phi, and BD is equal to sine of alpha over sine of beta. What remains now to find, so we've got an expression for that side, and remember we need side, angle, side to use the area rule. We need to find an expression for this angle. And we said we can use exterior angle of a triangle, so triangle angle DBE will simply be the exterior angle, which is beta minus theta. Okay, so we have this angle here, and we've got side. So area will be, so we're going to now write an expression for the area of our triangle. And remember, we find the area of the triangle, it's going to be half BE times BD all over sine of the angle in between. Because remember again, for area rule, we're looking for that V pattern. Okay, now we're going to substitute these expressions for BE and that expressions for BD, and we're going to end up with that. So I've basically just put this exactly as it's in here for BE and exactly as we found for BD. Now we're just going to clean up some of the algebra and see what we end up with. And because we're multiplying x by x, we end up with an x squared. So we got x times sine of alpha, and this belongs to our numerator. It goes up there. And at the bottom, we got 2 cos phi over sine of beta. So does that answer our question? Did we find an expression for the area of BED in terms of all our variables? Yes, we did. Okay, so our next question. In this figure, we've got P equals to A, Q2 is equal to B, and PQ is equal to H. Okay, and they want us to find, they're telling you PQ and SR are perpendicular to RQ, so they give us that this is 90, and they want us to find expressions for SQ and RS. So SQ is in this triangle, and it's pretty simple, okay? SQ belongs to this triangle. In this triangle, we've got 3 bits of information, and if you look carefully, we've got 2 angles, we've got no full pair. But we know we can find S1 because we have the other 2 angles, we can find S1 in terms of A and B. So that's where we'll begin. Because once we found S1, then we will have 1 full pair in terms of S1 and H. And we can use sine rule with that other pair as well. Okay, so S1 is equal to 180 minus A plus B. That's just using 3 angles of a triangle. Okay, so now using the sine rule, we can say that SQ over sine of the angle across it. So across from SQ we have A, and H, that one, and the sine of the angle across it, which was sine of S1. And S1, we had this expression, which was 180 degrees minus A plus B. Okay, let's continue. Right, so that's what we had written on our last slide. Now remember, what does this remind you of? Sine of 180 minus reminds you of second quadrant. And remember that we have, if we know that sine of 180 minus sine of 180 minus alpha equals to just sine of alpha. So we're going to use that rule to simplify this. And so we're going to end up with SQ over sine A is equal to sine of, it'll just become A plus B. Okay, rearranging this, we multiply throughout by sine A, and it ends up in our numerator on that side. So we've answered the first part of our question, which is SQ. Now we're going to find an expression for RS, and we're going to be using this triangle to find an expression for RS. Okay, so remember we've got something for SQ already. Okay, so but we need to find an expression for Q1. So because this is B and this is 90, Q1 will simply be 90 degrees minus B. Okay, because both angles are 90 and that's B, so Q1 is a complement of B. Okay, so sine of Q1 is going to be opposite over hypotenuse, and the hypotenuse in this case is QS. And remember, QS or SQ is what we found earlier. And we're going to just plonk that expression in for QS earlier. And what did we find QS to be earlier? Earlier, we found QS or SQ to be that. That was our previous slide. We had that answer. And sine of Q1, and Q1, remember, we found it to be 90 minus B. So I'm going to put in here 90 minus B. Now remember again, sine of 90 minus B reminds us of what? Sine of 90 minus B reminds us of the Coco rule again. So it becomes the co-ratio, which is cos of the complement, so B. Okay? So we're going to change this sine of 90 minus B into cos of B. Okay? And cos of B will now equal to this. Sorry, let me just erase my writing. Give me a second. Okay, so we're going to end up with, okay, so we've changed that sine of 90 minus B into cos of B, okay? And now we're just going to rearrange this because remember we needed to find for RS. So I'm going to multiply cos of B by this denominator here in the next step. And once I've done that, it's cos of B times H sine A over sine alpha A plus beta. And I've just got to just neaten up the algebra here. And there we go. We now have an expression for RS, which involves all our variables as they expected. So RS is equal to H sine A cos B all over sine of alpha plus beta. Okay, so that brings us to the end of this session. I hope you enjoyed it because the next session we're going to be doing examination type questions. Till then, bye.